So friends, now I will discuss about the equipment design for the static accelerated solvent extraction or pressurized solvent extraction. So different components that are involved in the instrument of ASE are reservoir for the fresh solvent. We need a high pressure pump to maintain the desired pressure. Then a thermostated unit like oven in order to maintain the required temperature where the extraction cell is placed. And we require a stainless steel extraction cell in order to withstand the high temperature and pressure conditions. We also require a back pressure regulator. What is the significance? We will discuss further. Then a cylinder of inert gas. I have told you normally we use nitrogen for purging the system, and a vial to collect the extract. Now, the significance of all these components is clear from their name itself. So reservoir for the fresh solvent, wherein the solvent that has to be used for the extraction process is stored. High pressure pumps basically suck the solvent from the reservoir and they fill the extraction cell with the solvent at a specified pressure, and they maintain that pressure. This thermostated unit will help us in maintaining the desirable temperature throughout the extraction process or the extraction time, and this thermostated unit contains the extraction cell, which is normally kept in vertical position. And a stainless steel extraction cell is preferred because high pressure and temperature conditions are required. Apart from these stainless steel extraction cells, certain alloy material is also used to manufacture the extraction cell and the tubing that is involved in the transportation of the solvent or the extract, because many times it has been found pH plays an important role in the overall extraction process. So if you want acidic or the basic pH condition during the extraction process, those alloy material help you in overcoming those corrosive corrosive conditions. Then a back pressure regulator. Now this back pressure regulator is important because extraction cell is filled with the powdered plant material, and we have to pass the solvent through that particular powdered material. Now when you have to pass the solvent through the powdered material, that powdered material will produce certain resistance towards the flow of the solvent, and this resistance towards the flow of the solvent through the extraction cell is indicated by the back pressure. So back pressure regulators can also be used to set up the maximum pressure limit. So if any kind of pressure increases beyond the set limit, then you will get an indication on your system so that you can take the precautionary measure. Further, we discuss about the metal frets that are placed on the extraction cell. So if those metal frets are clogged, then obviously they will also pose certain resistance towards the flow of the solvent. That also increases the back pressure. Therefore, these back pressure regulators are an important component of this equipment. Then a cylinder of nitrogen gas to clean the extraction cell or to purge the extraction cell, and vial to collect the extract. Now this image shows you the flow of or a flow diagram of the ASE system, static ASE system, wherein the solvent from the reservoir is taken up by the high pressure pumps. They pump the solvent into the extraction cell, which is placed in a thermostated unit at a specified temperature conditions, and these pumps work at a pressure value or the desirable pressure value. So once the extraction cell is filled with solvent and sample, the cell is allowed to subjected or to expose to the decided temperature and pressure values for specified period of time. So after the specified period of time is over, the pressurizing valve is open, which creates a pressure gradient which allows the extract to flow into the collection vial. Once the extract is collected in the vial, purging valve is open, which allows the nitrogen gas to enter into the extraction cell, thereby causing the purging or the cleaning or the washing of the extraction cell. Now in this image you can see different static mode ASC or accelerated solvent extractors manufactured by Dynex Corporation. ASC 100, ASC 200 and ASC 300. And these extractors, they differ in the volume they can handle, in the number of samples they can handle, and the pressure they can handle. So here is a small comparison of these three extractors. So ASC 100 can handle one sample at a time, whereas ASC 200 can handle 24 samples, ASC 300 can handle 12 samples. So ASC 100 and ASC 300 can handle up to 100 ml of the solvent, whereas ASC 200, since it can handle higher amount of samples, so the overall cell volume is 1 to 33 ml. Again, ASC 100 and ASC 300 can handle up to 10 megapascals of pressure, whereas ASC 200 can handle up to 20 megapascals of the pressure. Amount of the sample that is generally used in these three extractors range from 10 to 100 grams. Now here you can see ASC 150 and ASC 350 systems, which are nothing but the modifications of ASC 100 and ASC 300. Again, these are fully automated systems, and these techniques can also be used for the dynamic mode as well, but you have to incorporate certain modifications in the equipment, or you have to select certain interfaces so that you can go for the dynamic mode. Now this is a semi-industrial extractor by Buki, which is known by the name of speed extractor, and it can handle a temperature range of 30 to 200 degrees Celsius. As you can see the image of this extractor, this is a fully automated extractor that can be used for extracting various kind of matrices. Here you just have to put the sample into the extraction cell. The extraction cell is automatically sealed. The cell is filled automatically with the solvent. It can handle pressure in the range of 5 to 15 megapascal, having a cell volume of 10 to 120 ml. And at a time you can extract out 6 samples in this extractor. Now we move on to the dynamic mode of accelerated solvent or pressurized solvent extractor. So as I told you that in dynamic mode, solvent at a predetermined flow rate flows continuously through the extraction chamber, thereby the solid sample or the matrix or the sample that has been packed in the extractor, that comes in contact continuously with the fresh solvent. Now since the drug is in continuous contact with the fresh solvent, the solvent does not get easily saturated, and the concentration gradient is always maintained between the matrix and the solvent. And this maintenance of the concentration gradient helps or improves the overall mass transfer rate, and thereby increasing the overall extraction efficiency. Now since the equilibrium is not maintained between the solvent and the matrix, they never come in equilibrium, there is always a gradient is maintained, so the solvent saturation does not occur. But the major problem with dynamic mode ASC is that since the solvent is continuously flowing through the extraction cell, the extract or the product which we obtain is quite diluted, and since it is quite diluted, we have to go for the post extraction steps which are necessary in case of dynamic mode, such as concentration of your extract under vacuum or under specified conditions. Now mind you, this post extraction step was not necessary in case of static mode. So depending upon the volume that is obtained in the collection vial, we can decide whether we have to go for the concentration step of that extract or not. But in case of dynamic mode, we have to go for the concentration of the extract. Now we move on to the steps that are involved in the dynamic accelerated extraction. So first one is loading, and again loading will be same as we did in the static mode. Sample along with dispersing agent is filled in the extraction cell, and these dispersing agent, as I told you, they help in filling up the voids or the empty spaces or the empty pockets that are formed during the filling of the solvent, and thus they also prevent the formation of a compact sample bed, because if the sample bed is quite compact, the back pressure will increase, and since the back pressure will increase, more stress will be there on the system. One. Second, if the compact bed is formed, then solvent may not be able to enter into those compact places, thereby causing the non-uniform extraction of the sample. So we can also use various kinds of surfactants in the extraction cell. Now these surfactants basically help in transferring the compounds from the solid to either the micellar medium or to the sorbent layer in order to concentrate the target compounds. Then once the loading is complete, we move on to the filling of the extraction cell with the solvent. Now the flow direction is always from top to bottom, as we discussed that in the static mode also the extraction cell is placed in a vertical position. Now you have to allow the solvent to flow through the extraction cell at a predetermined flow rate, because the flow rate will have a direct impact on the extraction efficiency. If the flow rate is quite high, then obviously no doubt the extraction will improve, but yes, the resultant extract that you will obtain will be very dilute, because large amount of volume of the solvent will pass through the extraction cell during the specified period of time if you have selected a high flow rate. On the contrary, if you select a very slow flow rate, then obviously the volume of the solvent that is utilized during the extraction will be less, but since you have a very slow flow rate of the solvent, the mass transfer rate will decrease, and this will again have an impact on the extraction yield. So once the flow rate is decided, optimum flow rate is selected, then next step is the pressurizing and heating of the extraction cell. So you have to heat and pressurize the extraction cell at the desired pressure and the temperature values, and then you allow the extraction cell towards the dynamic extraction. So once the pressure and temperature conditions are maintained at the desirable value or level, then pressure outlet valve is partially opened to maintain the constant flow of the solvent through the extraction cell. And that is why, since this valve is open, it always maintains a pressure gradient which allows the solvent to continuously flow through the extraction cell, and hence we call it as a dynamic mode or the dynamic process. So once the extraction is going on and we collect the extract, we allow it to cool by circulating through a coil in a water bath, which helps in cooling of that extract, and then it is collected. So once the extraction is complete after specified period of time, cell washing is normally done. And in many cases we will see in dynamic, specifically in case of dynamic mode, cell washing is normally not done. In some cases, no doubt, cell washing is done by the solvent itself, but in many cases we will see that cell washing, or specifically if I say purging with nitrogen gas, is not required in case of dynamic mode, because the solvent is continuously flowing through the extraction cell, it is continuously washing the constituent from the matrix, and hence no nitrogen purging is required. Or in simple words, in dynamic mode, continuous washing of the extraction cell occurs, therefore we do not require any kind of purging or the rinse solvent volume in case of dynamic mode. We can also combine the two modes in a single apparatus, which we call it as combining of static and the dynamic modes, and this can be done by closing the inlet valve of the system once it has acquired the desired pressure and the temperature conditions. So once the pressure and temperature conditions are obtained, we close the inlet valve of the solvent and we allow the extraction cell to expose towards those set temperature and pressure values. And this exposure is for a specified period of time, and under this specified period of time, static extractions takes place. And once this preset time is over, we open the valves and we allow the solvent to continuously flow through the extraction cell, thereby we shift to the dynamic mode. Now this kind of combination of static and dynamic pressurized solvent extraction has shown to give better results in comparison when one of the technique is individually used. Next we have is the equipment design for the dynamic ASC. So most of the equipments will be same as that of the static mode. We have a solvent reservoir, we have high pressure pumps to pump the solvent into the extraction cell, we have a thermostat system to maintain the desirable temperature of the extraction cell. We also has, in addition to these, we have preheater before the extraction cell. So if you want to preheat your solvent before it enters into the extraction cell, that can be done in the dynamic mode, because the solvent that enters into the extraction cell, which is already at a very high temperature, is sometimes not recommended. So therefore it is always recommended to have a preheater which exposes the solvent to slightly elevated temperature before it enters into the extraction cell. Then next component is the extraction cell, and as I told you that extraction cell should be of stainless steel or of a suitable alloy which can withstand the corrosive, acidic or pH conditions if they are required during the extraction process. The next we have is the inlet and outlet valves in order to maintain a constant flow of the solvent through the extraction cell. So if you want to have a combination of dynamic and static modes, then also these inlet and outlet valves play an important role, because during the static mode we have to close both inlet and outlet valve for a preset time, and once the time period for static mode is over, we open these inlet and outlet valve in order to maintain the constant flow of the solvent through the extraction cell. Next component is the cooling unit. Now this cooling unit is required to cool the extract that exits from the extraction cell. So this is nothing but a sort of condenser through which the hot extract passes, and with the passage of the extract through that condenser, it gets cooled down and it is collected. A pressure restricted to maintain the desired pressure during the dynamic process, and last is the collecting vial. Now this is the setup or the flow chart of a dynamic accelerated solvent extraction, and here you can see the high pressure pumps, they suck the solvent from they carry the solvent from the reservoir, and with the help of inlet valve, these are passed to a preheater where they are subject to elevated temperature conditions before they enter into the extraction cell. Once they pass through the preheater, they enter into the extraction cell, and once, if you are combining both static and dynamic mode, I repeat, then both inlet and outlet valves are closed for specified period of time, and when that time is over, we open both the valves for the dynamic mode. So the solvent passes through the extraction cell, and that flow is controlled by the outlet valve, and from the outlet valve, solvent or the extract enters into the cooler where it gets cooled. And again, since specified time is required for the cooling, role of restrictor comes into play, because it restricts the flow of the extract through the cooler, and then finally the extract after cooling is collected into the collection vial. Now we move on to various parameters that can affect the overall pressurized solvent extraction technique. Now you can see I have divided these parameters into different categories. Those parameters which define the characters of a matrix, like nature of the analyte, what kind of compound or the secondary metabolites you want to extract, that also helps in setting us the parameters. Then what kind of bonding is there between the analytes, again that will help us in allowing to decide whether we have to adjust the extraction conditions to a specific pH or not, because as I told you that certain extraction require certain acidic conditions or basic conditions for better extraction. So depending upon their chemistry, their bonding, we can decide what kind of pH we require. Particle size is the next factor that governs or that helps in establishing the parameters. Obviously the particle size should be optimum. Too fine particle will make a very compact bed, bed of the sample, whereas very coarse powder will have large pockets left when the sample is packed, so large amount of dispersant will be required. That will decrease the overall extraction efficiency of the process. Then the presence of the moisture in the sample also governs, also helps in establishing the parameters. If moisture is there, obviously, as I told you, that moisture has a negative impact in case of pressurized solvent extraction. So therefore water content also helps in establishing certain parameters. Then type of the extraction we want. So the type of the extraction will be governed by the solubility of the constituent and the diffusion ability of the solvent into the matrix. If the solvents, if the solute or the analytes are highly soluble in the solvent, then obviously accordingly we have to go for dynamic or the static mode. Again, if the diffusion of the solvent into the matrix is slow, we cannot go for the dynamic process, then we have to go for the static process. So this is how basically the type of the extraction also helps in establishing the parameters for the PSC. And what kind of extraction mode you want to go, either dynamic or static. Factors affecting the overall extraction, like type of the solvent, because solvent is the most critical factor, or I will say one of the most critical factors that govern the extraction efficiency of any process, extraction process. Then temperature is there, time is there, pressure conditions are there. Then extraction enhancers, if we are using any kind of extraction enhancers or not, like dehydrating agents or drying agents, hydromatrix is one, and sodium sulfate is there. Any kind of dispersing agents are added to the matrix or not, or any other additives that are required for improving the extraction process. So all these factors, if we see, they will help us in optimizing the parameters that can affect the overall extraction efficiency of pressurized solvent extraction. For our convenience, I have listed certain factors irrespective of their class, and these are temperature, pressure, solvent and additives if they are required, solvent to feed ratio, then composition of the sample. And composition, mind you, if we go back to the slide, then composition, say the solubility of the analyte into the solvent, and also any kind of bonding is there between the analytes, or the analytes and the matrix is there. So all these factors come into the composition of the sample. Then particle size, and finally the extraction duration. So these are the factors. So friends, till now we discussed about the principle of pressurized solvent extraction, different modes of pressurized solvent extraction or accelerated solvent extraction like static and dynamic. What are the steps that are involved in these extraction techniques? What are the equipments or the design of the equipments that is involved in these ASCs or PSC? I also give an idea about various commercial extractors that are obtained from Dynex, and we also discussed one of the extractor obtained from Buki, which use this PSC, that is pressurized solvent extraction principle. So friends, in the next lecture we will discuss about all these factors that will affect the overall extraction efficiency of the pressurized solvent technique. Thank you.